Okay, I've already said, and I apologize for the fact that you can't see my whole head with this thing. It's focused with the board at a level that I can write on effectively. And I need a hole to stand in here, but then I'd trip and break a leg. So I'm not going to use that. And you have the advantage, you don't have to see my whole face most of the time. Okay. As I said already, this is an intermediate algebra course, MDE 60. Said already that it assumes that you know elementary algebra, okay? And that's not so, okay? Not that some of you and maybe many of you don't know elementary algebra, but have never seen a class where over a third of the class do enough elementary algebra to do an intermediate algebra. Now, you might have already had an intermediate algebra course, algebra 2 course. And if you remember that well, you ought to find this course pretty easy. But the first month or so, we're going to develop elementary algebra. We're going to start out with fractions. And I'm going to explain why we start out with fractions, because one of the hardest things in the course is adding rational expressions, which are nothing but fractions with a lot of symbols in them. Okay, so that comes later in the course, but we start out with fractions. I want you to understand fractions right from the very beginning. And that's basically going to be your assignment for next time. Now, open math. Did some of you signed up for open math for this course? Okay, if you haven't, do it. Just go to Canvas, read the first announcement. It tells you, gives you the course, gives you a website, gives you a course, gives you a course ID, and it gives you an enrollment key. Boom, you're in. Okay, and you need to be in order to do the homework. It's going to be due for 2 assignments. Okay, first one's very easy. Second one should be very easy, but you probably want to be careful about that. Okay. Another thing that I really have to say, I see way too many students who get the homework right every time, come into class, have a quiz, and can't do anything they did, which is a pretty good sign to me that they're getting some help somewhere. Maybe in many cases, it looks like they're just copying down answers they got from ChatGPT or some other AI. You don't learn anything by doing that. Okay. You need to work it out. You need to puzzle over it. You need to have a little patience. You need to come back. You try something else, come back, look at an example, read something, or ask ChatGPT a good question. Not how do you add these 2 fractions, but what's the principle behind adding fractions? What do I have to know in order to add 2 fractions? Tell it, I don't remember anything about fractions. What's the first thing I've got to know? It'll give you a good explanation. And that's a good way to learn from an AI. Okay? Ask it to solve your homework problem for you is fatal. You will not pass the course if you do that, unless your IQ is over 150. Okay? And me, I occasionally have people with IQs over 150. But usually not in this course. Okay? So again, a big caution, do not misuse online resources. Again, I see it. Majority of my students get good grades in their homework and can't pass the tests. Okay, means you're not doing your homework right. Okay, so there needs to be a dedicated notebook for this class where you write out your homework. Okay, now open math is going to give you the opportunity to do homework, to answer some of the homework on the computer. I want you to be writing out what you do. I want you to be writing out the steps of your solutions on a piece of paper and have them in your notebook and bring them to class. Because generally every day we'll have a quiz I'll ask you to lay your notebook out. I'll just take a look at it and see if you're getting it. I'm not going to put a grade on it. If you do it, you're going to get those points, but homework points will not pass the course. Homework gives you about 20%, and you need 70%, okay? The rest of it comes from the tests. So you got to be aware of that. So from the very beginning, make sure you write out your homework in good form. And good form is usually the form you see me using. Not that it's my way or your way. The form that I ask you to use is something you can build on. The form you're going to use for adding fractions is something that, if you do it right now, will make life much easier when you get to one of the hardest things in this course. Okay? And if you don't do it, you're going to have a very difficult time at that point. You might get a lot of other things right, but you're not going to understand that. Okay? Talking about adding rational expressions. You look that up, ask ChatGPT about it. You know, pursue a little curiosity if you have time, and nobody has time, do they? Okay. Okay. Your grading is going to be based on homework will contribute. And even if I know you're basically cheating your way through all the homework, I'm not going to police that. I'll give it to you automatically if you just put the right answers into ChatGPT. You get your 20%. Okay. 20%, here's your grade. Okay. And 20% of your grade is that. The rest of it, you got to get by knowing it. So you don't really want to do that with your homework. You don't really want to use a lot of outside aids and stuff to get the answers. Use outside aids all you want to learn the material, but not to get the answers to this homework problem or that homework problem. Okay? And if you miss a homework problem, you might tell AI, hey, here's the problem. Here's what I did. What am I missing? Be very good at that. Okay. Again, tell it you're a beginning, intermediate, or elementary algebra student. If it thinks that you're a beginning pre-calculus student, it's going to talk over your head. It'll adjust itself. Okay. So they're good uses. How many of you have used AIs? Anybody? Yeah, a couple of them. Yeah. Okay. Just go to ChatGPT and sign up. It's free. And I'll tell you, I'm still using the free version, and I've done some really high-level stuff. Incidentally, ChatGPT makes mistakes much more on the elementary stuff than it does on the graduate level, research level stuff. Okay? Because I probed it as deep as my knowledge goes. Okay? It's fairly deep. And found that it's really good. On the other hand, one time I asked it, okay, generate a dozen simple linear equations, simple kind of equations that everybody knows how to solve or will by Friday. Okay? And then give me the solutions. Gave me a dozen good problems with good variety and gave me a dozen solutions, none of which had anything to do with any of the problems. It just made up solutions. Okay? Now, I ask it to explain Liouville's theorem. That's kind of an advanced topic in study of functions of complex variables. Okay, graduate level stuff. Okay. It gave me just a wonderful explanation. Then I probed it a little bit. Okay. Because I hadn't thought about that theorem for, 200-300 years. So I probed it a little bit, asked it some leading questions and stuff like that. And I got a good refresher in about 5 minutes because it's really good. All right. So that's just a little perspective. It will make mistakes. If it's gonna make mistakes, it's usually with numbers and simple stuff. Um, okay, then as to the grading, basically gonna be just 2 tests. If you want more, you can ask. Okay, it's basically a midterm and a final. I'll be quizzing you every day. Okay, so I'll see what kind of progress you're making. We might have an earlier test. Test will generally be in the testing center. You go to the testing center when you have time, take the test. Tests aren't usually very long. If you know the stuff, you can get them done in well less than an hour. Okay. If you want to be really meticulous and write a bunch of stuff out and have time, you can take longer than that, but it's probably unnecessary. And the final will be a little longer. The goal is to learn enough algebra that you can at least go on and take pre-calculus with the pre-calculus support course. People want to jump from this course into pre-calculus. Okay. And many people have done that successfully, but only maybe 20% of the people who do that are successful. You need the support course. And if you don't need the support course, I'm going to tell you. Okay. So don't make the mistake of jumping from this into pre-calculus. We can't get there. We can't give you quite enough algebra to function well in pre-calculus unless you're also taking the support course where you get a little more support with the algebra and other aspects of the pre-calculus. Okay. So kind of keep that in mind. The goal here is not to prepare you for pre-calculus, although if you do a very good job, make 100 in everything, you're probably okay to jump into pre-calculus, okay? But if you get by this course, the 75% average, you are not ready for pre-calculus. 90% average, you're probably still not ready, but maybe. But that's say, I don't have any say-so whether you jump into pre-calculus or not. I'm just advising you. If you end up with a 90%, you should ask me. You think I'm ready to do pre-calculus without the support course? I'll tell you what I think, and then you make your decision. And no prejudice here. Whatever decision you make is okay, but I hope you make the one that works for you. Okay? All right. Well, there's the goal of the course. Now, there are all kinds of objectives listed in the syllabus. You should read those every once in a while and see that, oh, geez, you're 2 weeks into the course and I didn't know anything about that. And now I understand it perfectly. And I didn't know anything about that and still don't, but it's starting to make sense. Okay. Nobody ever does that because it takes time and it's hard to do things that aren't absolutely required and absolutely necessary. Another aspect of the course is going to be, I'm going to ask you to be writing things out. Tell me how you did things. I emphasize the fact that you learn by writing out the mathematics. You don't learn by choosing the right multiple choice without working something out. Okay. Most people, now different people have different learning styles, but 90% of the people learn by writing it out. Okay. I tested that for about 2 years. I tried to learn some fairly deep quantum mechanics without writing anything out. It wouldn't stick. Now, maybe it wouldn't stick just because I'm old. But as soon as I find time, I'm going to go back to it after a few years and write it out. And I think it's going to stick if I don't get any dumber. Okay. And I mean, stick to the point where I could teach a course in it without any reference to notes. Okay. All right. Okay, there are other technical aspects of the syllabus that we'll talk about next time. But I want everybody to be sure they've read it by then. Okay? Everybody's been to campus, right? Okay, you see the announcements. Announcements tell you to read the syllabus. Do what the announcements tell you. It's all in there. There's also a half credit site where you can do your open math homework if you're late. Okay. You only get half credit, but half credit's better than no credit. Something else I was going to say. Maybe I'm getting done. Well, I know that. Regarding the half credit page, anyhow, there's a link there for the half credit page. Okay. So sign up for both of those so you have it available to you when and if you need it. And there's no limit on when you can do the half credit, but don't put it off long because everything builds on everything else. If you put off an assignment until April, you're going to be missing something between now and April, and everything's going to be harder for you between now and then. Okay, so bite the bullet and get the thing done. Okay. Well, I'm going to go ahead and dive into a little bit of mathematics. If there are no questions, but let me pause the video. Oh yeah, another thing is, please do not speak or otherwise identify yourself. You know, disguise your voice if you cough. No, we'll just pretend that's somebody walking by in the hall. Okay. But don't speak while the camera is on, and yeah, we are recording. Okay, another thing that came up in the questions, somebody saw something about May the 1st. There is a college-wide calendar. Tells you when the last drop date is, tells you when the withdrawal dates are, tells you when the exams are, and so forth. It does not tell you anything about when the tests in this course are. It will tell you that the midterm will probably be a little bit before or a little bit after spring break. That's just typically when it happens. The earlier, the better, because the more quickly we can get through the elementary algebra, the more quickly we can get to the intermediate algebra, which is the real topic. Okay, don't like to have the midterm too late. And the midterm is usually over the elementary algebra, sometimes with a little bit of a gray area. There's kind of a gray area between elementary and intermediate algebra. It depends on how the class is doing and how quickly we're progressing. Now, we do have a schedule. If you look at the schedule of the courses in My Open Math, ignore it except for this week. Because I've got to take a good look at the class before I have a good idea how to concentrate different topics. Okay. Then I've got to reconcile that between the distance class and the seated class. Okay, so if you're a distance student, everything I've said is correct, except you don't have to worry about talking while the camera's on. Okay. And that's a privacy law thing. You know, you reveal that you're here and you just ask a question, even if it's a really good question, then you can be identified. And privacy laws, I think, go a little too far, although I think they're really important. What I think doesn't matter, if you do that, I can't use the video. Okay. Either that or I have to spend an hour editing the thing and I don't have an hour to edit the thing. Okay. So try not to do that. well, we want to talk about fractions. The reason we want to talk about fractions is this is only going to be up there for a minute. I'm going to erase it, but okay, you know how to add those? Say no. Unless you really do. Yeah, because to add these, you got to factor these things, see if there are any common factors between the denominators, and then put everything over common denominator and then add it. Since a majority of people at this stage have trouble adding fractions, we got to get over that so you can do this when the time comes. Okay, that might look intimidating, and that one would be intimidating. I don't think it's factorable. Okay, so I don't think you can do much with it, except just multiply the denominators and do all that stuff. Okay, so and what you get probably doesn't make a lot of sense in the end. But others, you know, it's an important skill. Okay, so what I want to do, and what I just wrote there was just a complicated expression with X's and stuff. I'm not going to read it. I do need to read these things as I write them in such a way that the transcript I get on YouTube can be edited. So I'm going to have to say a lot of stuff. The reason is this course, since it has a distance component, has to be ADA compliant, which means that a blind person should be able to follow what we're doing. Okay. So I kind of know how to do that. I just have to remember and train myself to remember to do it. So for that reason, I'm going to write out the first calculation that I want you to do. And then I'm going to see what you can do. Everybody got a piece of paper they can write on, or preferably a notebook you can write in. So remember, when I say a dedicated notebook, a notebook you use for this course and only this course. So you can easily find stuff you do in this course. And you should probably date every page, so you can always find what you're looking for, because it's a valuable aid in reviewing for an exam. Digressing once more. I find that people that do really well, even on the quizzes and so forth, don't appear to know what it takes. And I'm talking about 90% of students don't appear to know what it takes to prepare for an exam. And I hand out preparation problems and everything. I don't think they get used by most people. So we're going to be working on how to prepare for an exam. And I'll give you fairly frequent sets of problems outside the regular homework. Ask you to work them just to keep you in touch. If I don't ask you to add fractions between now and the midterm, there are two ways we can avoid the problem of you not knowing what to do on the midterm, which is one, give you about 100 problems to work through by hand, which isn't a bad way to learn, or just keep revisiting it so that every week you do a few fractions. And if you know how to do them, they're not going to be difficult. Okay.
Right.
If you don't know how to do them, well, you need to bite the bullet and review until they become clear. Does that make sense? Okay. So here we go. Here's a fraction. Function this already. I'm writing 2/7 plus 4/7. So can you write that out in standard mathematical notation? I'm gonna give you a second. I'm just gonna pause the camera, walk around, look over your shoulder. And it'd be nice if the... Now, there's something you need to know when things are written out in linear form like this. That is, you gotta divide before you multiply or before you add, okay? And everybody wrote it out correctly because you know we're talking about fractions, even if you don't remember the order of operations, you know how to write out fractions, okay? And that's exactly what I expected, okay? It's you divide before you multiply. So 2 divided by 7 is written as a fraction, 2/7. It's a 2 on top, 7 on the bottom with the fraction bar in the middle, right? And then 4/7 is written similarly, 4 numerator, 7 denominator, 4 fraction bar, 7 underneath that, okay? And then you can put the plus sign in. And that's how you can apply the order of operations. And you're going to see more complex expressions. Now, I find that, you know, like almost 30 years ago, I developed a really pretty extensive set of distance courses where I was teaching 19 different courses, spring, summer, and fall, every semester. It was a good system, okay? Around 2015, Google or Microsoft or somebody took away a key utility that had been there for 20 years. And I could no longer do it. Also, I was really happy to get back in the classroom. I'd had a heart attack a couple of years ago. People were concerned about my health, the fools. Okay. And you know, it's like a 24/7 job. And I like being in the classroom with people, so I was very happy just to let it go. All right. Now the point about that is, though, is one of my main concerns was I had to use this kind of notation, and I was afraid people wouldn't be able to handle it. People had no trouble with it. Okay. So I don't think most people are going to have any trouble with this. I gave them one exercise at the beginning of the semester, and everybody got the order of operations. And I did put some really confusing things in. And nobody really had any trouble with it. Of course, you know, as always, if you do a rigorous distance course, you lose 60% of your students. So maybe there's a 60% there that didn't do it. Okay. But most of the students that started got it, even if they didn't stick with the course. Okay. Well, okay, so there's our fraction. Now let's get the fractions. Okay, so you have fraction, and you see that 2 is a numerator, 7 is a denominator on the first fraction, 4 is a numerator, and 7 is a denominator on this fraction. Now, what does the denominator of 7 mean? That means you cut something up into 7 pieces, right? So imagine you got a stick and you cut it up into 7 equal pieces. Or you got a pie and you slice it up into 7 equal pieces. 7 is kind of a tricky number to slice things up equally into, but that's what I wrote, so that's what we're going to talk about, okay? You can imagine doing that. And this means, okay, I take 2 of them, okay? There's 2 of them, right? And now I'm going to add to that, I'm going to add 4 of them. So now what do I have? Well, I've got 6 of them, which is 2 plus 4 slash 7, okay? So the equation I got would be read 2 slash 7 plus 4 slash 7 equals 2 plus 4 slash 7. With the 2 plus 4 all on top. And if you're going to write it out in this linear form, that would be 2 slash 7 plus 4 slash 7 plus equals a left parenthesis. 2 plus 4, right parenthesis. So the 2 plus 4 is added before you divide by 7. So the right side would be 2 plus 4 slash 7. Okay. And finally, you get the answer that most of you wrote down when you wrote down the fractions. That would be 2 slash 7 plus 4 slash 7 equals 6 slash 7. 2 sevens plus 4 sevens is 6 sevens, because you're adding sevenths. Okay. Every seventh is equal to every other seventh. So you're adding 2 of them to 4 of them to get 6 of them. Okay. And that's big principle of fractions. That's what it means. Now, just side question, is that fraction bigger or less than 1? Say bigger or less. And everybody knows it's less because the denominator is less than the numerator, right? Okay. Okay. One more example. Let's do 5/8 plus 2/8. In other words, 5/8 plus 2/8. Okay. And if we write that as a fraction, we get 5/8 plus 2/8. And I'm going to change that is what I'm trying to demonstrate. I want 5/8 plus 7/8. I've just changed a problem. 5/8 plus 7/8 equals, well, 5/8 plus 7/8. And we know that's going to be 15/8 because, again, we imagine dividing something up into 8 parts. We take 5 of them, we take 7 of them, we got 12 of them. It's 12/8. People get confused on the addition of fractions, and they'll try to write this as 5 plus 7, that would be in parentheses if you're writing it out linearly, over 8 plus 8. Okay, and this is very wrong. And that would come out 12/16. This is wrong because of this. Okay? When I say because of this, what I just wrote out is wrong because after the first equal sign, I've got 5 plus 7/8 plus 8. I added the denominators as well as the numerators. Now I've got 12 things, but they're not eighths anymore. They're sixteenths. I took 5 pieces of whatever, added 7 of them, of whatever, and now I've got 12 pieces, but the pieces are only half as big. Okay, so I've got 16 pieces. You know, that's half as big as, that's twice as many as 8 pieces, means that you got to divide all your eighths in half. Okay, so that doesn't make any sense at all, but it's easy to write that down. Another way of saying that something's very wrong here is 5/8 bigger than a half or less. Okay, well, half would be how many eighths? Okay, 4/8, right? So 5/8 is bigger than 4/8, it's bigger than a half, right? And clearly then 7/8, since 7's bigger than half of 8, 7/8 is bigger than a half, right? So this is bigger than a half, this is bigger than a half, which means when you add them, you got to get what? You got to get something bigger than 1. If you add a half and a half, you get 1. But look over here, I got 12/16. Is that bigger than 1? No, makes no sense, right? Okay, so. And of course, everybody knows what to do. So we got our 5/8 plus 7/8 equals the quantity 5 plus 7, the quantity over 8. Now, when I say the quantity 5 plus 7, the quantity is easier to say than parentheses. You don't spit on people when you say quantity. Okay? You don't get the camera all messed up. For some reason, that's one of the ways this can be said, and this way I'll usually say it when I got parentheses. You'll get used to that. It's easy. Okay. So 5/8 plus 7/8 equals quantity 5 plus 7, that quantity /8, which is 12/8. Okay. And I want to see your work written out at least like this. Okay. I don't want to just see the answer. I know I'm going to see the right answer. We got the same denominator. I know you're going to do it right. So don't surprise me. Okay. Okay, well, that's it. If you got the same denominator, you just add the numerators because you're adding this many pieces and this many equal pieces. All the pieces are the same and you get some number of pieces. Okay. Now let's talk about what happens when you don't have the same denominator. Let's say we've got, do a simpler example here. Now I've written down a fraction and I haven't written it down in linear form. I'm going to read it in linear form. That'd be 5/8 plus 1/4. 5/8 plus 1/4. Okay. The denominators aren't the same. Now you can think about this. Let's say, take this piece of styrofoam here, just a linear piece of styrofoam, and break it in half. Actually, I probably have to cut it. It's got some facing on it. I'm going to cut that in half, right? Then I can cut each half in half. Then I can cut each of those quarters in half, and I have eighths. Does that make sense? Is that clear? So it wouldn't even hurt to draw yourself a picture of what eighths mean. And I'm going to draw one on the board. If you're visually impaired, I'm just drawing a little rod here, and then I'm cutting it in half, and then cutting each of the halves in half, and cutting each of those halved halves in half. So I've halved the thing, cut everything in half 3 times. Okay. Now I've got 8 pieces. Okay. 5/8 is what? That's going to walk 5/8 of a unit. I would walk, let's start at the left edge of this bar and count 1, 2, 3, 4, 5/8. And I draw an arrow from the left edge up to the 5/8 point with the head at the 5/8, right? So there's an arrow representing 5/8. Now I can do an arrow representing 1/4. Because when I divide it in half and then divide it in half again, that gave me a fourth. Half of a half is a fourth. There are 4 of these. There's 1, 2, 3, 4 of these things. I could even indicate the form in groups of 2, but it should be clear if there are 4 groups of 2 from one end of the bar to the other, so that each of these is 1/4. Now, if I want to add 5/8 to 1/4, I can add the 1/4 arrow at the end of the 5/8 arrow. And it's obvious where that's going to end up, right? Because 1/4 is 2/8, isn't it? If I group 2/8 together, I get 1/4. And there's a picture of the addition of 5/8 and 1/4. And you can see from this picture that this gives me 7/8. Okay. If you take anything and divide it up into 8 equal pieces, count 5 of them, put them in one pile, and then take 2 of them, you'll have 5/8 and 1/4. Put those piles together and you're going to have 7 pieces, and that's 7/8. You really want to understand fractions that well. Now, you're not going to visualize that if your denominator is too big, but it's easy enough to visualize that. Okay, so anyhow, 5/8 plus 1/4 equals 5/8 plus 2 times 1 slash 2 times 4. Okay. Now 2 times 1 slash 2 times 4 is the same as 1/4, right? Because the 2 under the slash can divide the 2 above the slash. Okay. Common term for that is you can cancel the common factor. 2 is a factor of the denominator. It's something that's multiplied by the rest of the denominator. And 2 is a factor of the numerator. It's something that's multiplied by the rest of the numerator. So I could get rid of the 2's and get back to 1/4. But I want 2 times 1 over 2 times 4. Why do I want that? Because that gives me, I still have my 5/8. The 2 times 1 is 2. 2 times 4 is 8. So I have 5/8 plus 2/8. And that, because of what we did earlier, must be quantity 5 plus 2 is the quantity slash 8, which is 7/8 read 7/8. Does that make sense? Now, that's not everything you need to know to get good at adding fractions. It's pretty obvious. If you multiply 4 by 2, you're going to get 8, right? What if we wanted to add 5/8 to 1/3? Eight's not a multiple of 3. 8 is 2 times 2 times 2, right? 2 times 2 is 4, and 4 times 2 is 8. There are no 3's contained within the factors of 8. There's a 3 here. We're stuck. This denominator doesn't have any common factors with this denominator. Okay. Denominator 8, denominator 3, nothing in common. So what we do is, now I'm going to write this out. As 5/8 multiplied by 3/3. 5/8 times 3/3. Now that has the same value as 5/8. If you draw 5/8 out here and then divide every one of these 8's into 3 pieces, you're going to have 24ths, right? Does that make sense? Whether you understand it visually or not, that's operationally how you're going to do it. Okay, so if we take 5/8 and multiply it by 3/3, it's going to come out the same. If I divide every one of these eighths into 3 pieces, then 5/8 is going to have cover 24 of them. Okay, that's worth thinking about. But there's the rule. Now, why did I multiply by 3 times 3? Or by 3/3? 3/3? Because if I come over here now, multiply by 1/3 by 8/8. Again, 8/8 is just 1. So all I've done is multiplied 1/3 by 8/8, which is multiplying by 1, has not changed the value, would not change where 1/3 is on this bar here. Okay. And having done that, well, how do you multiply fractions? Well, that's easy. You multiply the numerators and you multiply the denominators. Okay. Now over here, when I added the numerators and added the denominators, that didn't make any sense. I could make sense of this, and I'm not going to do that today. Just say, you can multiply the numerators, you multiply the denominators. If you draw little bars and divide things up, it works out. Okay, has to be true. So I multiply the numerator. Okay, 5/8 multiplied by 3/3. You multiply the numerators, which are 5 and 3. So I'm just going to multiply 5 times 3. And in the denominator, you multiply the 8 times 3. No, it's 5 times 3 / 8 times 3. That's your 5/8 times 3/3. Then we add the new 1/3 times 8/8. The numerators are 1 and 8, so the numerator is going to be 1 times 8. The denominator is going to be 3 times 8. So we write that as 1 times 8 / 3 times 8. And then we do the arithmetic. The 5 times 3 is 15. The 8 times 3 is 24. So we've converted our 5/8 into 15/24. To be sure we did that right, we could divide 24 by 3 and divide 15 by 3, and we get back to our 5/8, couldn't we? Okay. And then we have plus 1 times 8 over 3 times 8 is 8 over 24. And if we divide both numerator and denominator by 8, we get back to our 1/3. So these fractions, 15/24 and 8/24, are the same as 5/8 plus 1/3. Okay. And now we have the same size pieces. We've divided everything up into 24 pieces. We've got 15 of them. We've got 8 of them. We've got 23 of them. Okay. Now that's a very detailed explanation. There's one more example we need to do. Let me pause and see if anybody's got any questions. Okay, we've got one more. Oh, ouch. So I want to do 5/6 plus 13/16, that's 5/6 plus 13/16. Okay? We want to find the common denominator. Well, open math is going to tell you more than I'm telling you right now. Anybody remember the words prime factorization? Anybody ever heard those words? Ring a bell at all? Might. But it's been a while, that's one of those things you can easily forget. Okay. So we want to get the common denominator. Of 6. And we got 6 and 16. I'm going to change this second denominator. To 20. So now it's 5/6 plus 13/20. Common denominator 6 and 20. Okay. Here's how you calculate that. 6. What's the smallest number that divides 6? Show me with your fingers. 2 is the smallest. 3 also divides. 2 is the smallest, right? And 2 can't be divided by anything else. So that means 6 can be written as 2 times 3. And 3 can't be divided by anything else. When I say can't be divided by, you don't get a whole number. There's no whole number that you can divide into 3 to get a whole number. Okay? 20 equals. Okay, what's the smallest number divides 20? Show me the figures. 2. What's the smallest number divided by 10 that divides 10? Again, it's 2, obviously. Now I got 2 times 2 times 5. Notice 20 is 2 times 10. Since 10 is 2 times 5, 20 is 2 times 2 times 5. Okay. 5 can't be divided evenly. Can't be divided perfectly by any whole number. It's prime. So we mean by prime. See a little bit more of that in open math. Okay. So now well, I'm starting to write a question here. I don't want to write. Okay. Your common denominator means a number that each of these will divide into. Okay. Now I will tell you that if you just multiply 6 by 20, you get 120. So 6 has to go into it and 20 has to go into it, right? But we want a smaller number if we can get one, because we don't want to deal with big numbers. We don't want to deal with numbers that are bigger than we absolutely have to. Okay, so what denominator do we need so that 6 is contained in it and 20 is contained in it? Well, at least we need 2 and 2 and 5. The 2 times 2 times 5 that gives us 20. We got to have this denominator. We've also got to have 2 times 3, right? But we've already got a 2. We got 2 times 2 times 5. So the 2 here is covered by one of those 2's. But we need a 3. Well, that comes out 60. Okay. Now, when I write this, I'm going to write this as 5 over 3 times 2. So it's 5. 5/6 will be 5/3 times 2. 13 over 20 is going to be 13/2 times 2 times 5. Now I want these denominators to end up equal. So I'm going to multiply my 5/3 times 2 by the thing that it's missing. What's it missing? Well, the common denominator has a pair of 2's. So it's 3 times 2. I've only got 1 2 in 5/6 or 5/3 times 2. I need another 2. So I multiplied this fraction by, I didn't leave myself enough room, but I'll squeeze it in. I'm going to need a 2 in the numerator. And of course, I have to have a 2 in the denominator. So far I've got 5/3 times 2 multiplied by 2/2. Okay. My denominator would then be 3 times 2 times 2. Still don't have 2. 3 times 5 times 2 times 2. I'm going to need a 5 as well. And so there it is. Now when I multiply this first fraction out, 5/3 times 2 multiplied by 2 times 5 slash 2 times 5, it's going to come out with this common denominator, which multiplies out to 60. Over here, the 13/2 times 2 times 5, which is my 13/20, would be multiplied by, well, the only thing we're missing here is the 3. So we multiply by 3 over 3. So we have 13/2 times 2 times 5 multiplied by 3/3. And then we multiply out the numerators. Okay, the first two numerators are 5. Okay. In the first term, 5/3 times 2 multiplied by 2 times 5/2 times 5. I multiply the numerators. I get 5 times 2 times 5. The denominator is multiply 3 times 2 by 2 times 5. I'm going to write that as 2 times 2 times 3 times 5. Smallest numbers first. And then we're going to add 13 times 3. Sorry, 13/2 times 2 times 5 multiplied by 3/3 is 13 times 3 over 2 times 2 times 5 times 3. Then, if we wish, we can multiply out the numbers. My first fraction has a numerator 5 times 2 times 5. That adds out, that multiplies out to 20. The denominator 2 times 2 times 3 times 5 is 60, and that's in both cases. And then 13 times 3 is 39 over 60. Now, 20 over 60 is now 20. You know, if I make it through May, I'll have been teaching 54 years here. First time I ever made a mistake. Don't believe it. Okay. I did 2 times 2 times 5 when I did this because my eye caught the 2 times 2 there. I do that to keep an eye on me. Okay. It didn't make sense. I looked, that's 20 over 60. That's 1/3. That's not 1/3. 5/6 is not 20 over 60, which is 1/3. So you want to kind of compare these and make sure they make sense. Anyhow, I could reduce this to 5/6, but that would defeat my purpose because I want to add these. I've got a common denominator, so I'm going to add the denominators 50/60 plus 39/60. The numerators are 50 and 39, so we do the quantity 50 plus 39 quantity over 60, avoiding the fatal error of adding the 60s. We think about what we're doing. It gives me 89 over 60, which could be written as 1 and 29/60. And that would be handy if you want to locate this on a number line. Okay. But right now, the improper fraction is easier to do calculations with, so we're going to keep it improper unless we have need to do the mixed number. And open math is going to ask you for both. Okay. Now I urge you to go through as much detail as I've gone through to cement these ideas in your head for later use. Okay, the better you cement them now, the less trouble they're going to give you later. And they always give people trouble later. Okay, so take a little extra time, give it a little extra effort if you possibly have the time and force yourself to do it. And do it in such a way that you're really going to understand it better than you ever have. Okay. Open math, your first assignment is the introduction to open math, which is due today. So get that done today. I tend to be a little forgiving at the beginning. And, you know, if you don't do it today, you're going to have to do it at the half credit page. But I would probably, if you get it done, by tomorrow, before the next class, before you have to do the homework, I'd probably go ahead and transfer that one for full credit. But do it today. It only takes 10 minutes, if that. All right, good luck. I'm glad to have you here. Glad to be working with you. Let's nail the fractions so we can go on and do other stuff.